Hi, everybody. Unfortunately, I am under quarantine orders until probably around Wednesday, December 9th, unfortunately. But just because I am not there doesn't mean we're not going to move forward as usual. All right. So I made a video here that's going to go over the review questions you had for homework. I will also post this on Google Classroom so you can go back to it. And you should have a sub there that does understand the math that can also help you. So please feel free to ask them questions. Feel free to have them pause the video if I go too fast. But remember, you can always go back and watch this later on to help you when you solve the evens, which is what you're going to do once I'm done going over these. All right. And then my plan is on Wednesday for the remote day, I'm planning to log in and, be with you guys from home that day. So definitely compile any questions that you want to save for me, and we can go over those on that day. All right. So for now, let me go over how to do these questions. Hopefully you look back in your notes to, go back and see how you would approach a question like this if this came up on the test. So again, the test is moving forward as usual. And so Thursday will be the blue group and Friday will be the gold group taking the test in class. All right. So whenever you're sketching an angle that's in radians, remember the denominator is going to set how you label your quadrantals. So I'm going to go around my quadrantals. This would be 0 radians here. And instead of pi radians, I want to put it in terms of the denominator. So 1 pi is equivalent to 4 pi over 4. Then a 90-degree turn up here on the positive y-axis would be halfway to 4 pi over 4. So what you do is you take the numerator here and cut that in half. So now that's going to be 2 pi over 4. So every 90-degree turn is 2 pi over 4, and you're basically just adding 2 pi over 4 as you go. So this is 2 pi over 4, 4 pi over 4. Whoops, you add another 2 pi over 4, making it 6 pi over 4, and then finally 8 pi over 4. Since this is a positive angle, we're going to rotate counterclockwise, and that lands me right in quadrant 3. Okay, so the direction says sketch an angle in standard position. That just means it starts at 0 radians and rotates, in this case, counterclockwise, and state the quadrant. So this is quadrant 3. Make sure you show the rotation as well. Okay, rewrite the given function in terms of its reciprocal and find its exact value. All right, so secant and cosine are reciprocals. So what we're going to do is find the cosine of pi over 4. We'll find the value of that, and then with that, we should be able to come up with the exact value of secant pi over 4. So pi over 4 is not a quadrantal angle. It's one of our special rights. So you're going to access your special right. When you get to the test, I would have this written down, maybe on a piece of scrap paper or something. And remember, across from the pi over 4s, we're going to make them 1 and 1, which would make our hypotenuse rad 2. So now, since pi over 4, these are both pi over 4, you can pick whichever one you want to be your reference angle. I'm going to pick this one down here, and then it's adjacent over hypotenuse for cosine, right? So cosine's adjacent over hypotenuse, which is 1 over rad 2, which would make secant the reciprocal hypotenuse over adjacent, which would make this rad 2 over 1, which is just rad 2. Okay. It's been a while since we've converted, so let me just remind you that there's 2 ways that you can convert radians to, degrees to radians. So there is sort of like an all-purpose formula. It's a proportion where any angle in degrees is to radians in the same proportion, in the same ratio as 188 degrees is to pi radians. So you could fill in the 600 up here. And then, this conversion is the basis of all your conversions from degrees to radians or vice versa. You cross multiply. This is just one way to do it. and you're solving for the radians, and you want to keep it in terms of pi. So all you're really doing here is reducing 600 over 180. So this is one way to do it. That's with a proportion. The other way to do it is using dimensional analysis. So if you have 600 degrees, you put that over 1, you would multiply that. Now, in this case, the degrees would have to go in the denominator so that I could cancel out those units, and the radians would have to go in the numerator. So then with your dimensional analysis, you multiply across, you get 600 pi over 180, and you end up in the same spot. And then this would be radians. Okay, so we have to reduce 600 over 180. How would I do that in my head? First of all, I'd get rid of the zeros, right? And then, 6 goes into both of those. 6 goes into 60 10 times. 6 goes into 18 3 times. So we get 10 pi over 3. All right. Another way you could approach that too is for all these multiple choice answers, you could have plugged in like 180 in for pi and just reduced them all until you get to 600. Okay. All right. In which quadrant does the terminal ray 7 pi over 3 land? Okay. So same idea as before. Now my denominator is 3. So I'm going to label this 3 pi over 3, which would make halfway to 3 pi over 3, 1.5 pi. Whoops, that shouldn't say 13. That should say 3 over 3. So now every 90-degree turn is 1.5 pi over 3. So that would make this 4.5 pi over 3, 6 pi over 3. I have to keep going, right? So I'm going to add 1.5 pi to 6 pi, and you get 7.5 pi over 3, which means I'm doing a full rotation and then landing in between 6 pi over 3 and 7 pi over 3. So this is quadrant 1. Okay. All right, sorry, I just want to make sure I was still recording. Okay, this one has also been a while since we've seen this. So when you read this word problem, it's talking about Jack is planting a border of flowers in the shape of an arc along a circular walkway. So the first thing I'm going to do, wow, it's a terrible circle, but is draw a circle. Okay. Then it says if the circle has a radius of 5 yards, so we'll put that in, and the angle subtended by the arc, which measures 1.5 radians. Okay, so basically what that means is you have a central angle that's 1.5 radians, and the arc that it subtends the arc is basically that right there. I kind of think of these as like slice of pizza questions where the crust is the arc, and then the angle has to be in radians, by the way, which it is, right? So that's good. It's in radians. And then the radius, of course, is, from the center to the edge. Okay, so this is actually how we developed what a radian was. So you can use one of two formulas. If you have a central angle in radians, so it's got to be in radians, you would get 1 radian if the radius and the arc length were equivalent. So for any angle in radians, it's the ratio of the arc length over the radius. So in our case, we have the angle 1.5 or 1.5 equals, we don't know, over 5. All right. So now once you plug in what you have, then you solve for what you don't have and you cross multiply. So S equals 5 times 1.5, which would be 7.5. So you can use this formula for whatever you're missing and cross multiply and solve for what you don't have. Some Algebra 2 teachers use SOAR, all right? So if I cross multiplied here, you would just have to remember that its arc length equals theta times radius. So I always tend to use theta equals S over R, the ratio of those two. I find that I remember that easier. This one I find that students forget where the equals goes. So you say SOAR, but you got to remember that it goes after the S. Okay, number 11. The big thing you got to, when you read through this, is the fact that this is the unit circle. With the unit circle, it's the only time that cosine is cosine of the angle is the same as the value of your x in that coordinate. So we see we have an angle here, theta, and then when that angle reaches and touches the point on the unit circle, right? So the coordinates would be x, y, but because it's the unit circle, which we derived earlier, we found out that the x value is cosine and the y value is sine. So it's telling me down here that my angle is 3 pi over 4. So I'm going to make my own diagram here. And because I want to just make sure I know where 3 pi over 4 is, I'm eventually going to have to figure out my reference angle and different things like this. So this diagram is great, but you should make your own once you know what the angle is. Okay, so I'm going to label here in fourths. So this rotates 2 pi over 4 and an extra pi over 4. That brings me to 3 pi over 4. So then what I'm going to do on my diagram is drop my perpendicular, label, right, based on where I am in the circle. So what we're going to do is we're going to get the reference angle in a minute. The reference angle is going to represent this obtuse angle that landed in quadrant 2. So when we're in quadrant 2, our adjacent angle, our adjacent side is negative, opposite's positive, hypotenuse is always positive. Then what we need to do is figure out what is our reference angle, right? We need an angle that's inside the triangle. So if I rotated 3 pi over 4, I'm leaving a gap right here in between 3 pi over 4 to 4 pi over 4. So how much more would I have to go? I'd have to go 4 pi over 4. Now remember, reference angles are always positive. So now I know this is my pi over 4 triangle, right? Special right. So this side is going to be 1. The side here is going to also be 1. It happens to be negative because it's on the adjacent. And then our hypotenuse is rad 2. Okay. So what we want is we want the value of x. So that basically means I want the cosine of 3 pi over 4, which is going to be equivalent to just finding the cosine at this reference angle right here. Okay, so the cosine of 3 pi over 4 is going to be equivalent to just finding the cosine at this reference angle, which is adjacent over hypotenuse. Okay, so this is what I was talking about in class. Even though if this was a short answer, you wouldn't have to rationalize for me. You do need to know how to rationalize in case it's a multiple choice. So you would rationalize the numerator and rationalize the denominator, which means you're going to multiply the numerator by and the denominator by rad 2. So we get choice D. Okay, I'm going to stop recording because this cuts me off at 15 minutes. So I will have another recording after this that will finish up.